In this video, we're going to briefly discuss the properties of matrices, focusing on identities and inverses. So, what is an identity and an inverse? These are terms that you've known and you've used. It's just a matter of how do you remember, what they actually are. So, if we simplify, so just talking about integers now, talking about the additive identity. Now, what that means is what do we add to keep it the same? Because you want it to be exactly the same, identical to what it was before. So, 5 plus what number as an integer is equal to 5? And you know that that number would be 0. A multiplicative identity would be what do we multiply by to keep it the same. I want to multiply 5 by some number and keep it identical to 5. You know that that is the number 1. Right? So additive identity and multiplicative identity are different because they're different operations. But we understand what it means. It means that we keep it the same. Whereas the inverse means what do you add to give us the identity? Since we know that 0 was the additive identity, 5 plus what number brings me back to 0? You know that's the opposite of 5. Multiplicative inverse means what do we multiply by to get to the identity of the multiplication, which was 1. So the inverses are different for addition and multiplication, but they mean the same. It brings you back to the identity. This would be 1/5. So how does that happen with matrices then? So if you have an additive identity, what do we add to keep the same is still the same exact question. So if we come back to the additive identity, so we're looking at this and we say 1, 2, 3, and 4 plus something has to be 1, 2, 3, 4. And if you remember your matrix addition steps, you know that you just add corresponding elements. So 1 plus something has to be equal to 1, which is how we know that this is equal to 0. 1 or 2 plus something has to be 2, so 0, 0, 0. So all of this is just going to be 0, and that is the additive identity in order to get you back to be the same. So that is your additive identity. Whereas the multiplicative identity is what do we multiply by to keep it the same. Now this one's a touch more tricky because we know that for matrix multiplication, there's more than just one step. I don't just take the corresponding elements and multiply. Matrix multiplication, whatever this value is, let's call this A, and let's call this B. So in order to come up with this element, I need to do 1 times A plus 2 times B, and that has to equal 1. A lot of students would mistakenly say that the multiplicative identity is 1, 1, 1, 1, because, well, that's what you multiply by, but it's not true because of this statement. You have to multiply across the row and then down the column in order to come up with this element. So the actual multiplicative identity is a combination of addition of the same and addition of 0. So this is going to be 1. This is going to have to be 0 because 1 times 1, okay, that works. 2 times 0, that gets us there. And then what also has to happen is this 0 and that element is 1. So this is your multiplicative identity for a 2 by 2 matrix. So 1 times 1, 2 times 0, 1 times 0 and 2 times 1, and then you keep on going down the line for the rest of your identities. So that helps us figure out what we should be multiplying or adding by in order to get back to the same identical thing. Inverses then are going to be a little bit different. So what do we add by to get back to the identity? So we now know the additive identity for matrix multiplication is going to be 0, 0, 0, 0, and we know that the identity for multiplication is going to be 1, 0, 0, 1. So what do we add by to end up with zeros, and what do we multiply by to end up with that identity matrix? So we take a look at what we need to do to find the additive inverse. 1 plus what number is equal to 0? And again, since addition, you just add your corresponding elements. This is going to be the opposite of 1. This is going to be the opposite of 2. This would be the opposite of 3 and the opposite of 4, because now when we add corresponding elements, that gets us back to the original. So if your original matrix is C, this is just the opposite of C. And then that would be your other matrix. And that gets us back to the additive identity. The multiplicative inverse, again, slightly more complicated. This is A and that's B. And then because you're going across the row as you go down the column, then you have 1 times A plus 2 times B has to equal 1. And you'd have to create a system of equations for all of these four unknowns in order to come back up with that multiplicative identity as the output. So, luckily for us, when we do this, we use our calculators right now. So we can use our calculators to be able to help us find that additive inverse. And if we use our calculator here, we'd end up with this as our inverse. So you have 1 times negative 2 plus 2 times 1.5, and that brings you back to 1. 1 times 1 and 2 times negative 0.5 brings us back to 0. And you would just go across the row and down the column to find each of those things. So how do we actually do that then? With our calculator, because that can be a complex process that we need to do. So let's take a look at a different matrix, a 3 by 3 matrix, and try to figure out what that is. So I'll show you on the calculator then. You go into your calculator, and I've already got it entered in here. So you go to your second matrix button, go over to edit, and I'm going to create a 3 by 3, and you see I already have that matrix entered in here. So all you need to do is use this button, which is right where the matrix is, which is the x to the negative 1. That doesn't necessarily mean the negative 1 power, that means the inverse. Right? So negative 1 means the inverse. So if I go to second matrix and I select matrix A, all I have to do is hit that button, and so this notation here means the inverse of A. And so you hit enter, and you've got your matrix, and you can arrow over to see all the elements, or I could just do math and convert it into a fraction, makes it a little bit easier for me to look at, and that is my inverse matrix, as you can see here. So now when I have these two matrices, what that means is that if I take matrix A and I multiply by the inverse of A, or vice versa, other direction, inverse of A times A, we're going to get the identity matrix for a 3 by 3, which is ones down the column, down the diagonal. Ones go down the diagonal for a 3 by 3 matrix, or all square matrices. So there is, of course, a way to find the inverse by hand, but we are going to save that for a different class for you. So all you need to do when you need the inverse is to use your calculator to be able to find it. Click on the link at the very bottom here in order to go to the next video for this lesson, which is on solving a few examples with these concepts.